Six Sigma is a management strategy to achieve a business goal. It was originally developed as Motorola Company's business initiative. So back in 1984, these guys from Motorola Group, Galvin, Smith, and Dr. Harry, they were on a process data over time for an improvement project. They use statistics, and this method usually give us data on a distribution graph like this to analyze production measurement, and we can get how many products are accepted or rejected in percentage. Sigma is a statistical term meaning a standard deviation of a process about its mean. We use mu symbol for process mean, and we use sigma symbol for standard deviation. For specification limits, we use SL. This limit is very important and corresponding to problems that we might get in production processes and product designs. What Six Sigma method does is to adjust this limit according to production or operation issues. Most American companies at that time, they usually use specification limit of 4.5 standard deviations regardless of operation conditions or problems. They won't accept measurements with more than 4.5 standard deviations. We usually get normal distribution for manufacturing processes, and the graph shows a bell-shaped curve, and the area under the curve shows you the percent accepted and how many percent are within the specification limits. The mean is at the center, and it is the standard we want most of our measurements to be. It is at 0 sigma, telling us there's no deviations. In Motorola model, instead of traditional 4.5 sigma specification limits, they went all the way to 6 sigma by widening the limits. Again, the point here is in Six Sigma, we move these limits as calculated by the product design engineers to meet customers' quality requirements. Why did they move it? Because they came to know it is needed to increase percent accepted. What Motorola Group found was that in a normally distributed process like this for operations that include complex assemblies, the mean of the process tends to shift, and it shifts 1.5 sigma to the right. That is 1.5 standard deviations away from the standard mean. The black mu on the graph is for standard mean, and the red mu is for the real mean from data over time. This shift tells us that production processes are not ideal, and we have environmental conditions to be accounted for. These conditions are different operators or different process durations, so on. So they come to know if you use a narrow range of specification limits of 4.5 sigma, the mean shift of conditions is going to give you only 3 sigma worth of percent accepted. So the only way to eliminate this error is to widen the specification limits to include mean shift. So now you can see the shifted data. The red curve would include up to 4.5 standard deviations. This will also satisfy the environmental conditions and also what most American companies want 4.5 sigma as standard. So here is the data table for ideal and Motorola Six Sigma adjustment for that distribution. Here is the standard deviation axis, and you can see the ID average in black and shifted average considering conditions in red. The shift is 1.5 sigma, so the shifted distribution goes to 4.5 standard deviations. So at 6 sigma specification limits, we get 99.9999998% accepted for ID data, with only 0.02 defects per million opportunities. That's what we expect in ID distribution. In Motorola model data, they included environmental conditions and time. So the new mean was 1.5 sigma away from the standard mean. So the percent accepted is now at 4.5 sigma away from the new mean, but the point is the real data stays within the specification limits. Therefore, it has 3.4 defects per million opportunities and 99.99966% accepted, with operation conditions also accounted for. However, if you overlook these operation conditions and miss to adjust your 4.5 specification limits, then your data will only include 3 sigma worth of percent accepted. And so we will only get 99.73% accepted with 2,700 defects per million opportunities. So in order to reduce the high number of defects, we must adjust our standard deviations to Six Sigma and move up specification limits to include environmental conditions. This way, Six Sigma method eliminates variations by including 1.5 sigma worth of percent accepted. So what you do is get this difference in percentage by subtracting 99.73 from 99.99966 and change the percent to number and then multiply with the cost of a unit, and that's your profit. And we're talking about millions of dollars for billions of products produced. Now you can apply this method to many different types of industries or business processes. Here is a simple example of Six Sigma specification limits. In Six Sigma, we must know how close our data is to the average we want to go. Here X is mean and Y is sigma. More importantly, we must know the conditions surrounding the production process, operations, and customer requirements, their needs or their limits, and the size of the customer population. Then we can decide how many sigma fit between average and customer limits and adjust the specification limits. Again, these limits are corresponding to customer requirements. Now here is a simple shipping orders example. Let's say our average is 3 days delivery at 4.5 sigma, but our customer, the shipping line, requires 9 days at 6 sigma to deliver an order. So we will move up to 9 days to allow them to deliver the order, so we won't miss the opportunity and at the same time eliminate variation. Here, we're not talking about an order, we're talking about thousands of orders that this company can ship in a year for us. If we include this company to do the job, we get 99.99966% accepted delivery completion. That's how Six Sigma grow the profit. Six Sigma approach is most of the time used for business improvement to improve quality and to achieve breakthrough profitability. This method plans to eliminate variation, and it is done by finding causes of defects in products and processes for improvements and bottom line savings. Then it enhances accuracy by carrying out a highly disciplined process. The process includes the use of statistics, development of new perfect products, and or delivery of consistent services. For these reasons, this method is really a systematic process to find true root causes of problems. By eliminating the variation and enhancing the accuracy, the outputs important to the customers are mainly focused to produce. And these outputs are product quality, perfect design, and consistent services. And this way, Six Sigma is used to maintain customer satisfaction and to gain competitive edge. Then we listen to the customers and apply Six Sigma to what they want to improve continuously. So it is now called a continuous quality improvement approach. How is it carried out? Well, we do it systematically. We use six-step protocol. We use popular DMAIC or DMADV. The six-step protocol starts with identification of the product attributes wanted by customers. Then we group them. And next step, we determine how these groups are controlled. After that, we decide maximum tolerance for each group, and we control the process variations. Finally, we change the design of products to achieve Six Sigma performance. For DMAIC, we do the same thing. We start with defining what customers want, then we measure and understand the process and risk. After that, we analyze data and identify importance and waste. In the next step, we improve design and implement the new process. Finally, we control the new system and verify long-term capability. DMADV is the same, but the D stands for design and V is verify, but they work relatively the same as DMAIC. Six Sigma method also uses lean, design of experiment, design for Six Sigma, and total quality management tools as needed. Here are the key points for Six Sigma method to review. We definitely use statistics. And another very important thing is you have to adjust the standard limits according to the conditions in operations, production, processes, and customer needs, wants, and requirements. Then this Six Sigma method is very powerful because it really eliminates variation and enhance accuracy. So we can produce better quality products and we can deliver services consistently. And don't forget to use the highly disciplined method DMAIC, DMADV, and six steps protocol, and so on. And that's all we have to know for Six Sigma method as an overview.